Welcome to this demonstration of the HDF5 virtual file driver for HDFS. In this demonstration, we will show you how to copy an HDF5 file into an HDFS file system, how to list the file structure by running h5ls, how to print detailed information by running h5dump, how to extract some data using the same tool, and then finally, how to use Hadoop streaming to collect data across multiple HDF5 files. Now, to do this experiment, to repeat this exercise on your own, there are certain prerequisites that need to be in place, including a version of the HDF5 library at the time of this recording, HDF5 1.10.4, that includes the virtual file driver for HDFS. You also need a compatible version of Hadoop. Currently, that would be version 3.1.1, although what you will see here today may very well work with other versions of Hadoop. And you need a running instance of an HDFS file system, be that on a local machine or an HDFS cluster. And for all these things, you need also to configure your environment appropriately. There are three important environment variables that need to be configured for your environment for this to work. These are Java home, Hadoop home, and the class path. And then to locate certain shared libraries, also make sure that in your LD library path you have included the directories containing those shared libraries. And then finally, just for convenience, just for your convenience, you want to be sure that for binaries such as HDFS and some of the HDF5 tools, you have included them in your path. To verify that your HDFS file system can be reached in the usual way, you might want to verify that by just listing the root directory of that file system as shown here using HDFS dfs-ls. So if I execute that, then I get a listing of the root directory of the HDFS file system. Next, this is the part proper of the demonstration where first we would like to copy an HDF5 file into HDFS, and that could be an existing HDF5 file or netcdf4 file. If you don't have one, it's very easy to create a new HDF5 file using the h5 make group command. So in this case, I'm just going to create a file called sample.h5 and create 3 groups in it, and then show that that really exists. So if I execute that, it was just created for me. And now I'm going to copy this file into the HDFS file system, into more specifically the temp subdirectory in the HDFS file system. And the command for that is very simple: HDFS dfs, copy from local, sample.h5, HDFS hostname /temp, and then just to verify that the copy was successful, I'm going to list that file and then should get the correct information and confirm that the file indeed is now in HDFS. A copy of the file is in HDFS. So if I execute that, everything is fine. The file indeed arrived there. Now we can, or you can use again your own file. It doesn't have to be sample.h5. Use your own file if you prefer that. Next, Now we would like to apply some of the HDF5 command line tools to that HDF5 file in HDFS, and sort of a standard tool to accomplish that is H5LS, and we really use it as we would use it with local files, except for that we have to tell the tool to use this virtual file driver instead of the default file driver for POSIX file systems. And the way we do that is there are two additional options. Number one, there is this option --VFD equals HDFS, and then typically your HDFS cluster is not your local machine, so you will have to specify the host name and port of your HDFS cluster name node, and in this case it's jelly ad hdfgroup.org, and the port is 8020. And then I just do a recursive listing, that's the -r on that file tmp sample.h5, but obviously now tmp refers to TMP in HDFS. So let's execute that. And we would expect to see 3 groups, and here they are, or more precisely 4, including the root group. And we can, of course, do that with a slightly more complex example. Here I have, for example, a netcdf file, a netcdf4 file, and since it contains quite a large number of objects, I'm listing just the first 50 path names. I believe there are over 300 in this file, but so we don't need to see them all. So if I execute this, it lists all the path names in that file. That's fine. Now, another very useful command line tool is h5dump that can give you very detailed information about individual objects, groups, data sets, and so forth in a file, types for data sets, and you can dump data sets entirely, and we'll come back to that in a moment. So let's, for example, use our sample file to show the object properties and the super block, that's the P, capital B. And then again, at the moment, we have to tell this tool explicitly not to use the default virtual file driver for POSIX file systems, but rather we tell it to use the HDFS file driver. And unfortunately, the naming of the options is not consistent across tools. So as we just saw for H5LS, it's --VFD equals HDFS. For H5dump, it's --file driver equals HDFS. But then where we specify the name node of the HDFS cluster, the syntax is the same, where we provide the so-called HDFS attributes. Let's execute that. And this is the expected output that we expect to see from a h5dump command. And then likewise, I can do a similar command on that larger file. Again, I'm going to limit it to the first 50 lines because the output is rather long, and I'm not dumping at this stage any data. So let's execute that. And here's the output as we expected, very detailed. And now, of course, sometimes we would like to see data, and in this particular example, unfortunately in our sample file, there are only groups in there, there are no data sets. But in this slightly bigger example, there are plenty of data sets, and these data sets tend to be rather large. So what I'm going to do is I'm going to extract just a 10 by 10 block of a data set, and the data set that I chose here is at this path, output flux function profiles, colloidal flux area. And I'm just picking a hyperslab or a rectangle here. It's a 2-dimensional data set, and I'm picking a rectangle where the lower left-hand corner of that rectangle is at position 0, 0, and the upper right-hand corner is at position 10, 10. And so if I execute this, I would expect to see some data, and here it is. These are this is this 10 by 10 block of this data set that is 22,845 by 33. Now that's nice. Now, of course, oftentimes you would like to examine multiple HDF5 files rather than an individual HDF5 file, and you would like to use environments such as Hadoop streaming for task coordination and task generation and so forth. And if you're not familiar with Hadoop streaming, I recommend you check out the official documentation. The gist is you can use Hadoop streaming to use pretty much any executable command, including standard Unix commands, C code that you have written yourself, or in any other language like Python. You can use those as mappers and reducers to process data. And sort of here is the sort of the pattern how you invoke this command, and this is what we are going to do. I wrote a simple mapper and reducer in C that basically does the following. For a collection of HDF5 files, for each individual HDF5 file, it traverses the objects in that file and reports back the type of the object, whether it's a group, a data set, or a data type object. And then that's what the mapper does. And the reducer basically counts then on a per file basis how many groups, how many data sets, and how many data type objects there are, and reports that back. So the final result that we would expect would be a listing of file name plus 3 counters that tell us for each category of object how many objects of that type are to be found in that file. And the way how we identify these files to this Hadoop job is I have created an input file, or more precisely in this case, 2 input files that basically list the names of these files. So these 2 input files are called input 1 and input 2, and I can show their content here. So their content is basically just a long list. Well, it's not that long of HDF5 files, and there's also a netcdf file among them. And the source code for the mapper and reducer can be found on GitHub, and I encourage you to go there, get it, compile it, and then try it yourself on your own files. Of course, you will have to modify these input files, and the reason I'm using 2 input files is simply to create multiple splits. These files are so small that Hadoop wouldn't split these files on its own and sort of create multiple mapper tasks, whereas by creating multiple input files, we can then artificially create multiple mappers. And in this case, we use 2 mappers and 3 reducers. And yeah, the whole command to execute this Hadoop streaming task is shown here. And again, if you want to run this in your own environment, you will have to modify, the location, the HDFS cluster, the directory in which you find the input files, and where you want to write the output. And then I've just added 2 commands here that the Hadoop task will fail if you're trying to create output files in a location that exists already. So just as a precaution, I'm deleting these locations here before launching that Hadoop task. And yeah, let's execute that. And the output is going to be rather lengthy, but I'm not going to examine it here. I'm just going to show the final result. Again, we expect to see a list of file names followed by 3 counters that tell us how many groups, data sets, and data type objects are to be found in a given file. And so here's the output from the Hadoop task. And here at the end, we see the output that we expect. So for each file name, we see G for groups, D for data sets, T for data types, that, these are all HDF EOS files, for example, and they are from the same mission. So we would expect a consistent number of groups and data sets across the board, but then we sprinkled in here a few extras. So here's, for example, the file that the netcdf4 file we used earlier that has 35 groups and 305 data sets and 7 data type objects, and a few other examples here. In summary, what we've seen is that you can use this virtual file driver for HDFS to just continue doing the things that you are used to doing on your POSIX file systems, in some cases NFS. And this works with the standard HDF5 command line tools and other tools. And as I just showed, you can also use this virtual file driver in your own code, especially in situations where you would like to use a tool in the Hadoop ecosystem, such as Hadoop streaming. Thank you.